It's one of the suggestions we made. Because in the spring on DC, it was important spring on DC. To make it more sexy somehow. But I never have you used it? Classic standard on top of and is that nice?
Okay, so don't get it here. I think we have 1 minute to go, so. Okay, so welcome to this presentation on DevOps for the enterprise, or as I call it in the title, DukeOps. That was just kind of selling it in for the conference papers, but it's kind of catchy name, but it's really about DevOps for the enterprise. I must admit that when I wrote the code demos for this presentation, I got a little bit carried away, and so the demo may show a little bit other things than actually the presentation is about, but it's a pretty cool demo, and if you like playing around with lots of different kinds of technologies, and it's kind of, it fits in the topic anyway. But it was more fun coding than creating slides. Anyway, about myself, I've been coding Java since '95. I wrote my first hello world there at university. I've been professionally coding Java since '98. And currently I work for Cybercom, which is a consulting company in Malmö in southern Sweden, where I do regular consulting and also have the opportunity to go around speaking at conferences like this. I'm a member of the expert group for JSR 371, which is MVC for Java EE8. So if you have questions about that, you can just get a hold of me afterwards. I'm also in the expert group for JSR 375, which is Java Security API. I'm not sure if that's going to be targeted for Java EE 8, but I think so. That expert group has just started. Today, I'll talk about DevOps, and DevOps in the context of in the enterprise. First, I'll just quickly go through my view of DevOps. Then look at how DevOps impacts the people working with it and the choice of technologies you're using, and also with Java EE in mind, see how it fits into the DevOps agenda and the Ruby code. So DevOps. What is the problem that DevOps is addressing? Have anyone seen something like this anytime? Or got this reaction? Like, this is the essence of DevOps. You know, it worked on my machine. Well, it doesn't work in production. Well, whose problem is that, right? And if you see it, what developers want when they work on technology is they want change. We want to use new technologies. We want to implement new functionality. We want a changing system. Whereas the operator perspective is they want stability. They don't want any changes, because if you introduce changes into the system, it gets unstable. So that kind of collides. So DevOps is about getting both to want the same thing, that you want change and stability. And if you think about it, who else is interested in change and stability. Yeah. What about business? Right? That's where you make money. You want change and stability. You want new systems, new functionality in your system, as long as the old system also works, so you keep earning money. So that is what DevOps is about, in my view. So how do we choose the right technologies and architecture and organize ourselves to achieve both of these objectives? Because they're kind of conflicting, right? There's change and stability. And that brings us into the topic of enterprise DevOps. And let's first look at organizations and what that's impacting DevOps. Most enterprises are organized in something you can call functional silos. You have departments doing different things, and you have handovers between the departments. Like you have a business department that writes some requirements and hands it over to development, that produce some code and then hands it over to operations. And there are almost always pretty tight walls between these departments. So how do we introduce DevOps in a silo-organized organization like this one? Do we just add a DevOps department? Or doesn't that just introduce another silo, another wall between things? So whenever you hear about we're setting up a DevOps department, or we're hiring DevOps, or we are setting up a team of DevOps to help us communicate between developers and operations. You're failing. You haven't understood DevOps. You're not right? And if you look at what Jez Humble says, there's no such thing as a DevOps team. You can have a team that facilitates the DevOps stuff that you need to have your organization to work. But you can't just introduce a silo between the development and operation and call them DevOps and put them in the corner and say, hey, fix things. So, what do we do then? Do we merge development and operations into one department, and then sit together and call it the DevOps departments? There is actually a name for this, and that is NoOps. And one particular example of organizations who have this kind of organization is Netflix. They are organized into teams that have responsibility for one particular domain of their business, own service or whatever, and they have responsibility for the whole life cycle. So that may work for some organizations, but not for all. So another way of doing it is to actually let the specialists do what they're good at. You create some kind of culture that enables developers and operations personnel to do what they know best and implement DevOps. So it's not often you get all the resources that are equally good at everything. So you want to have the good operations people with their mindset of thinking stability, and you also want the good developers thinking functionality without being having an obstacle of always being stable. But you want a combination of those. And that brings us into people. That can often be an obstacle or a resource for DevOps. It depends on what kind of people you have in your organization. And if you go back to the developer, they want to develop new cool stuff, right? And the system operations, that they don't want to change that much. They want stability in the system. The developer wants to function on functionality. They hate boilerplate code. They want to just code the business component, and that is what they're supposed to code. They don't want to code the plumbing and wiring. the operations want monitoring, and they want to know when something happens, if something happens, and they want to know it before the customer calls you. The developers want to be productive, right? They want to have tools and softwares and processes and everything that is as lightweight as possible, so they're not in the way of producing the business code. The system operators are always busy. You can never get hold of them, right? So it's if you have time-consuming deployments, they're paying for them. They want things that goes fast. So setting up a new server or deploying a new application, a new version or something should be as fast as possible. Developer wants ease of development. They want to do what they're supposed to do and not fight with their environment. They don't want any bloated stuff or hard to do environments to work with. Operations want robustness. They want to recreate and create new environments without hassle, for example. So this was just a couple of things, a couple of characteristics that I'm trying to address later in the presentation, but it's important to know that they have different mindsets and they want things easily, but they have different objectives for it. And it's not always you can get people that can really do two things equally well. Well, most often you're very good at shooting or skiing, but it's not that many that are equally good at both. So you want to have the experts in both departments, but you want them to work together. So let's look at some of the architectural characteristics that we, oh, here's going fast, okay. You want it easy to develop, you want it easy to maintain, you want infrastructure as code, and you want it configurable, you want it monitorable, and everything, and that brings us into microservices. And why do I bring up microservices here? It seems like every talk here are talking about microservices, and this is no exception. And what has microservices to do with DevOps? Yeah, it often shows up that if you introduce the DevOps culture in an organization, you often end up with a microservice-oriented architecture. And that is why it's often mentioned in the same context. And microservices is what I'm going to demo a little bit of afterwards. So what about Java EE then? You don't very often hear Java EE mentioned in the same context as microservices. It's often you hear about embedded containers or Spring Boot and etc. So before we dive into that, let's look at the concept of containers. And I don't mean containers like Docker. I mean containers like an application server container, a Java EE container, or a web container. And look at the differences. If we look at a Java EE container, that is characterized by, it is a specification that you deploy your WAR file into, and you can code to interfaces that are implemented in this container. But you're not dependent on the actual implementation. It's just something that's there that you can use. But all Java EE 7 applications need to run in a Java EE 7 compliant application server. And the different servers provide the implementations. They may differ, but that shouldn't matter for you, in theory. If you look at, for example, Spring-based applications, they are most often just relying on a server container or similar, like Tomcat or Jetty. And inside the WAR, you bring in all the Spring stuff you need to wire together the application. So this is kind of a way where you bring your container with you into your web application container. So everything the application needs to run is brought in with it. That makes the WAR file will often be bigger and have slower deployments and stuff than a Java EE7 application. Then you have the context of embedded container. That is when you actually take the serverless container and package it into your jar file or whatever and run it. An example of that is Spring Boot. So let's dive a little bit deeper into the concept of containerness. So usually when you build an application, you have some kind of hardware, or it could be a virtual machine or whatever, but usually you have some kind of hardware with the operating system and a JVM. Since we're a Java conference, it's assuming we're running Java applications. But usually this is the stack that you expect is there when you start up your application. It's not very often that you actually wire together the hardware yourself or build an operating system, or even bundle the JVM. You may, but often you rely on this being there. And you build the application on top of it. Then after a while you discover, I need support for example, security, I need persistence, I need messaging, I need transaction support, I need some kind of integration framework because I'm calling other systems, I need something for presentation. And one way you can do this is actually build it yourself within your application code. And then you look at still the JVM on top of the operating system and hardware is your container where you base your application on. Or you can do it that you buy or use a framework like Spring, for example, and add components on top of your container, and then you're kind of treating this as your container where you build your application on. Probably see where I'm going with this. Because this is stuff that is already there in a Java EE container. So that means that you can focus on the functionality, you can get the ease of development, you get rid of the boilerplate code, and that is on the developer side. That's what the developer wants, right? You want to write business logic without caring about the plumbing. And for the operations guys, they are happy to have the more stable stuff underneath that doesn't change. So here the only thing that changes is actually your business logic on top of it. And you rely on a well-tested application server underneath. And you also get more stuff for free, like scalability and such. But then again, Java EE is so bloated, it's so hard to write, it's so difficult, like EJBs are pain, it's so much hassle to write an EJB. Well, come on, it's 2015. This is an EJB today. You can't get any easier than this. And this is a transactional, scalable, secure service. So let's, we've been talking a little bit of microservices, a little bit of Spring Boot, I've mentioned Docker. These are more or less the three themes that most of the presentation I've been to here has been mentioning. So what is better than actually combining these into a demo? And then I'll try to link it back to this presentation afterwards. but I hope you bear with me, and that it's actually the code that matters, right? So in a microservice-based architecture, you somehow need some kind of lookup service. In this example, you have an application A that typically registers with some kind of discovery service. And you have an application B that looks up to see, is A there? Okay, then I can register myself. Or the other way around. And you have another C that looks up or registers itself to a discovery service. I'll show you a couple of examples. First of all, I'll show you a little bit of Spring Boot. Because when you talk about DevOps, you often end up with microservices. And when you think of microservices, you often end up with Spring Boot. And then I'll show you how you can actually might just as well think Java EE. Let's just mirror the display. So let's look at a simple Spring Boot application. And what this does is it starts the application, and I have some configuration annotations there. And I say that it is a Spring Boot application, and then Spring Boot takes over and does its magic. And then I have an annotation here that is enable Eureka client. And Eureka is something that has come out of Netflix, and that Spring has brought into their Spring Cloud. So it's ready to use discovery service. So what this is saying is this application, when it starts, should register itself with Eureka. But then we also need to have Eureka, right? So let's see how we can implement the simplest version of Eureka. And that's exactly the same. I just called the class name or something else, just for fun. But it has Spring Boot application, and it has enable Eureka server. And that is what is good about Spring Boot, that you get things for free. So let's start up Eureka, and then I'll just use Maven Spring Boot plugin to run it. Is the font readable, or should I shut up a little? You see, it starts up with its usual Spring Boot stuff. It takes a while to start because it brings in everything and wires it up and bootstraps pretty much stuff. And then I'll start up the client. And the defaults for Eureka is that it takes about 30 seconds for it to register. If I go into my web browser, there, and see here that Eureka is running, but currently there are no instances available. So if we just wait, like, usually takes about 30 seconds, then it should be registering. This is, of course, configurable. You can have 10 seconds or whatever. There, something happens. And now we can see that we have our client registered. And we can also get information about it and go to it. It doesn't have any, again, just another one. It doesn't have any, do anything, or I haven't added the actuator and other cloud stuff, but you can see it's here. If I stop the client again, it will disappear. That's pretty cool, right? But what does this have to do with Java EE? Well, let's see if we can do something of the same. You see, it's so easy with Spring Boot to just add an annotation and then you have your replay enabled. So that is something that we maybe want to do with Java EE as well. So what I've done there is to create a Java EE-based service that is kind of the same as Eureka, just much simpler because it's just a demo. And if you wonder about the name, I call it Snoop Service. I couldn't come up with something better, but Snoop, it snoops around and finds services. So, and what this one does is that it exposes a WebSocket endpoint that lets a client register. And it just adds the client to a client registry, which is just a singleton. It could have been, I could have used JCache or whatever, but here I just have a register method and a deregister. And also have a get client so I can show the clients in the browser. Also have a very simple UI that just lists the clients. That's more, and it also has a, when a client registers, it returns a URL to a health endpoint, so that the client can ping it once in a while and show heartbeats. And the health endpoint just checks, is it up or is it out of service? So it's very, very crude and easy. And I could run this in my application server, but to make things a little bit more challenging, let's use Docker. So I have my Docker file here. And what it does is that it takes a Docker image I have created, which has Ubuntu with Wildfly on it, and just adds this work in the deployments folder, and it's installed and run. So if I write here doc, let's see if I have it. No history. I write Docker run, and I want it interactively. I want it to expose port 80, I think I'm using 81, I think I would like. It runs on 8080. There. You see, it fires up the Docker container, runs Wildfly, deploys the application. It has a couple of HIPs, and it's up. But it's at least as fast as Spring Boot, possibly faster. And now I'm running a full-fledged application server. So I'll just also show you a little Docker feature. And that is, I want to do something now, because I want to see some log levels that aren't default set, and I haven't put the log levels in my application. And I want, as a DevOps guy, to be able to set the log levels runtime. And JBoss or Wildfly has a JBoss CLI that we can use to set the log levels. And what I'm doing here is I've just created a simple script that just sets it Docker exec, and I have a parameter which is the running instance of Docker. And Docker exec says, in this Docker instance, run this command. And this is JBoss CLI, and I said connect to the management console and set log levels. So to be able to do that, I need to find out which is the ID of my running instance. and I only have one running here. And then I can run the log levels on that IDE. Now I set the log levels in my Wi-Fi so it will log when we connect it. Let's have a look at the client. That is also using some Java EE specific stuff. I have a annotation, so you can say enable Snoop client, and also have a little bit more functionality than Spring provides, that you can also actually here specify the application name, or you can use it in a configuration file. That's up to you. And I'm also using a feature called CDI extensions. So when this application starts up, I check for enable Snoop client annotations, and then I register, I pick up the information I need and just store it in a simple singleton. And this singleton is used by a WebSocket, which is the client endpoint, Java EE WebSocket client. That's how easy you do that. It's a singleton, and it starts on startup. And what I do when it's started is that I check if Snoop is enabled, which the CDI extension has found for me, and I just register it. And the register method just sends a message to the WebSocket endpoint. And then when I get the message back, I answer the heartbeat that it's up. And also what I do is that I start a timer service with every 10 seconds. I want the timer method of this EJB to be called, so I send a heartbeat every 10 seconds. Of course, this should be configurable, but right now it's hard to do. Also, just since Spring supports or Spring Boot, like if you look at the example out there, it kind of people want to use YAML as properties definitions nowadays. And I guess it's because it's more human readable than properties files. But a property file you can just load into your properties object, but a YAML file is, I don't think there is support for that yet, so I just had to write a simple YAML parser. And it just uses the Jackson YAML extension, so it's not very big deal. But then how do I use this then? Well, I can create a simple web application that is based on Java EE, and I want to add the Snoop functionality. So I add one dependency, and I can then create a class called application config, for example. You can call it whatever you want. And the only thing I need to do here is annotate it with enable Snoop client and call it JJ's Snoop, for example. And that's all there is to it. Then I can also, just the same way as with the Spring Boot, I can have the application YAML file to define where my Snoop endpoint stays. And as you see, since I'm running Ubuntu Docker on Mac, I have to specify an IP address. This is not running on localhost. Otherwise, I could run it on localhost. And this is the endpoint for the application I just started in Docker. So if I build this one, and this one I'll run in Wildfly. starting up the entire service. It takes a little while, but here it registers the application, and I'm doing the heartbeat to the see, I found the annotation, and I registered with the Snoop, and I send a message, and this will go every 10 seconds. You see, here it sends. And if I look at in the Docker container, you can also see that it receives the information here. And of course, we can have a look at the fancy web UI that I made and see that it has this demo, which is not the name I used in the annotation, because it picks the name from the application from the properties file. So you can override it. And if I stop it, it will deregister using the pre-destroy method. So if I go to my application server and just undeploy it, you see here that it's deregistering. And it also in Docker says that it's now out of service. And hopefully in the web UI, it won't be there anymore. So it's kind of similar to Eureka, right? And it's not that hard. It wasn't that many lines of code. But what I'm doing here is actually what I'm saying that we shouldn't do. And that is to create your own stuff when there are things. Like if you have an underlying container, use that container and make the operations guys happy, rather than creating your own framework for things. So it would be much better if I could actually register with Eureka, right? And not create this server my own way. And that is actually fairly easy. Eureka has a REST interface. So it's very easy to create a client for it, and you can actually also, if you invest a little bit into it,